Let us move on to the next problem, which is problem number 2 in the lecture. And this one is telling that figure shows a vertical circle in which two chords drawn from one end of a horizontal diameter subtend angles of theta and 2 theta at the center. The times taken by the bid to slide down the chords are in the ratio 1:k. Show that cos theta is equal to 1 upon k square minus 1. This is the figure given with the question. A vertical circle means a circle lying in the vertical plane. Suppose this point is the center of this vertical circle, and I have also shown the horizontal diameter of this circle through this dashed line, and let me call this horizontal diameter to be AB. Now they are telling of two chords subtending angles of theta and 2 theta at the center. So here is the first chord. Let me name it AC, and another chord is AD. According to the question, if I join this point C to the center O, then the angle subtended by the chord AC at the center of the circle is theta. On the other hand, if I join D to this center O of this circle, the angle subtended by the chord AD, that is given to be 2 theta. Two conditions have to be considered. In the first case, a bid is allowed to start from rest at the point C and fall along this chord CA lying in the vertical plane. We assume that this chord is frictionless, and suppose the time taken by the bid to travel from C to A, that time is taken to be T1. In another possibility is that the bid is allowed to fall along this chord DA, also smooth, and the time taken by the chord to start at rest from the point D and come to this point A, that time is taken to be T2. According to the question, this ratio T1 is to T2 is equal to 1:k. And we are required to prove that cos theta is equal to 1 upon k square minus 1. This is the question here. Let me put this question in difficulty level 2 and approach the problem. First of all, we shall consider this triangle AOC. In the triangle AOC, if this angle is theta, well, you can see here that the other two sides, that is OA and OC, they must be equal to the radius of this circle. Therefore, this is an isosceles triangle. And since three angles together make 180 degree, we can say that this angle CAO and the angle ACO, they must be equal. So I am writing it here. The angle CAO is equal to angle ACO, and each of them must be equal to 180 degree minus theta. Theta was the third angle, that is this one, the angle COA, and if together they become this divided by 2. This is coming out to be 90 degree minus theta by 2, isn't it? Once we know the value of this angle, either CAO or ACO, let us apply the law of sines in this triangle. We have done this law in properties of triangles under trigonometry, and applying this law of sines. According to this law, the length of any side of a triangle divided by the sine of the opposite angle is a constant. So, referring to this triangle AOC, we might write down that the length CA, talking about this side, divided by the sine of the opposite angle, that is sine theta. CA by sine theta must be equal to some other side, that is I am taking to be OC, say. So length of OC is equal to R, the radius of this circle, divided by sine of opposite angle, but opposite angle has been found just now to be 90 degree minus theta by 2. So I have got R divided by sine of 90 degree minus theta by 2. Once we get this, from here we can get the length of the chord CA in terms of the radius of circle, that is r into sine theta divided by sine 90 degree minus theta by 2. But then I can write this sine theta as 2 sine theta by 2 into cos theta by 2. This is submultiple angles formula, and sine 90 degree minus theta by 2 is of course cos theta by 2. We get rid of cos theta by 2 in numerator and denominator, and I am getting the length CA can be expressed to be twice radius of the circle into sine of the angle theta by 2. That is my first important step result. In a similar way, let us find out the length of this chord DA. This time we consider the triangle that is AOD. When you consider the triangle AOD, here this angle AOD is equal to 2 theta, and once again the length OA and the length OD, these two sides have same length equal to the radius of this circle. Therefore, the triangle AOD is also isosceles triangle having these two angles equal. Therefore, we might write down that angle DAO must be equal to the angle ADO. You understand here DAO is this angle is equal to the angle ADO, and each of them should be equal to, well, 180 degrees, all three angles together. One of the angles AOD is twice theta, so 180 minus 2 theta divided by 2. This is coming out to be 90 degree minus theta. Once we got any of these angles, we can once again apply the same law of sines in the triangle AOD, and could write down that by the law of sines, the length DA, this length divided by the sine of the opposite angle, that is sine of 2 theta, must be equal to any other side. Let me take OD. This length is equal to radius of circle divided by sine of opposite angle. This angle has been just now found to be 90 degree minus theta, isn't it? Either this angle or this angle is 90 minus theta. So you have got r divided by sine of 90 degree minus theta. From here, we are getting the length DA is equal to r into sine 2 theta divided by sine 90 degree minus theta, which is of course cos theta. But sine 2 theta can be written to be using multiple angles formula, 2 sine theta cos theta. So numerator is coming out to be 2r sine theta into cos theta divided by sine 90 minus theta is cos theta. Get rid of cos theta and I'm having, this is twice r into sine theta. That is my equation number 2. And remember, this is the length of the chord DA along which the bead might also come down. Both the chords CA and DA are assumed to be frictionless here.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.